We'll now look at one last way to organize differential equations, which is linear or nonlinear. So what exactly do we mean by that? Let's start by considering a very generic differential equation, a1 of x times dy dx plus a0x y equal to f of x. So my a1, a0, and f are just saying that we have some kind of something going on involving only the variable x. We call that term f of x the forcing function, which will make more sense later as we move on. But the f of x is the forcing function and the a1 and a0 are the coefficients. This is a linear first order differential equation. So now the question should be why? Why is this linear? Well, there's two real things that we need to make a differential equation linear. The first condition is that the dependent variable terms and their derivatives are polynomial terms of order 1. So we're going to look at some things that actually violate this. So for some non-examples, we have 3 dy squared over dx plus e to the xy equal to cosine x. And that has to do with the derivative. We're taking the derivative of y squared instead of just the derivative of y. So that would violate this. The second one, x to the 4th times dy dx squared minus xy equal to 4. This has order 2, it's raised to the 2nd power, and that's not what we want. So that would violate it. And for the last one, x squared dy dx plus e to the x sine y is equal to x. Well, sine y isn't a polynomial term. I can't have this inside of another function like a sine or an ln. So these would all be non-examples, in particular violating condition 1. So what about condition 2? The second condition says that coefficients and forcing function terms must either be constant or a function of the independent variable. So the things in front of the derivatives as well as the forcing function must be either just a constant number or must depend only on our independent variable. As an example of something that violates this, if I have the second derivative of y with respect to x plus y dy dx equal to ln of x, this term here is going to cause issues because the coefficient of dy dx is y. That's the dependent variable, not the independent variable. So that would violate it. On the other hand, if I have x cubed dy dx plus ln xy equal to e to the x, this would be a linear differential equation. We have the dy dx term and the y term, which are both polynomial terms of order 1. And the coefficients are x cubed and ln of x. Both of those are only independent variable. And my forcing function is e to the x, also independent variable.